Hello, everyone. Good afternoon, good morning, good evening, whatever time you are deciding to watch these videos and complete this assignment. I hope you're having a wonderful day and weekend, or hope you had a wonderful weekend and you were able to do something good for the old mental health-aroo. Just a few announcements before we get totally into the mix. The first one is that the weather conditions for Thursday are looking a little bit shaky. So right now, it's forecast for a pretty strong atmospheric river event to occur Thursday into Friday. So depending on how the forecast goes in the next for the next couple of days, we may actually just hold class on Zoom for Thursday. So please just keep an eye on your announcements. I will be sure to let you know if I do decide to do that. I'll let us know at least by Wednesday whether or not it'll be for sure yes or for sure we'll be in person. And if we are in person, if I do decide to still hold class in person and you truly don't feel comfortable coming to class, your safety is more important than missing a class. So just let me know and I can excuse your exit ticket. So that's the big thing to get out of the way. So just keep in mind and keep on the lookout for that. So with all that said, let's get into today's lecture. So we started talking about wind systems, right, and how they cover the planet. And so what I want to talk about now is some of the climatological impacts of some of these wind systems. And we talked about the intertropical convergence zone, right? That's where the two Hadley cells meet near the equator. And it's actually pretty cool. It's a really neat feature that we can observe just like through satellite imagery. Every good outfit has a good accessory, right? And Earth is no different. But what's neat and what we saw when we left class on Thursday is that the ITCZ moves a little bit. It doesn't really stay in one location for the whole year, so it shifts a bit. And these shifts in the ITCZ can actually bring about monsoon climates. So a monsoon climate is defined as a climate that's dominated by one very wet season and one very dry season around areas near the equator, near-ish the equator. And it's technically defined as a wind shift. And that wind shift brings about different moisture contents of the atmosphere. So we're going to talk about a couple of different places in particular and observe their potential monsoon climate feature. So you may be wondering to yourself, why would California not be in this mix? And that's because we are too chilly. So our climate is technically defined as a Mediterranean climate, where we are dominated by a wet season and a dry season, but we stay relatively cool, especially in comparison to regions around the equator, like in India or in Africa. Though, and we will point out that Tucson, Arizona, which is right down in here, actually observes a monsoon climate in the summertime as well. So kind of cool, I think. So to help us visualize this idea, I got some maps. Got some maps for us. So if we recall, atmospheric pressure and atmospheric circulation, for regions of high pressure in the northern hemisphere, we would see clockwise motion, right? Whereas with low pressure systems, we observe counterclockwise motion. In the northern hemisphere, it's really important to keep that in mind. So here we're looking at the month of July, and these blue lines are called isobars. They're contours of constant pressure. And then we can see where the ITCZ is generally located for the month of July. And what I want to point out here is if we were to imagine this counterclockwise circulation around this particular low over the Middle East and India, if we were to kind of put arrows onto that, we would see that air is traveling over the Indian Ocean. And as it's traveling over that ocean, it's picking up moisture. And then when it interacts with the land masses, then it basically dumps all of that moisture that it took so much time picking up. Alternatively, in the winter time, so here's excuse me, a similar map, but instead we see a huge pattern change, right? So if we kind of go back and forth between July and January, we see a huge shift here, specifically over Eurasia, right? So if we try and go back and forth here, kind of toggle back and forth between these images, you can definitely see that there's no longer a low situated over India. It's been now replaced by a region of relative high pressure. So here we would see clockwise motion. And with that, then instead of the air predominantly going over the water and coming onto land, it's now coming from land and going out to the water. So it doesn't have that moisture tap, that all of the available moisture from the Indian Ocean. Now it's coming off of basically the Tibetan Plateau and the Siberian tundra. So then just the air is just simply not nearly moist enough. And so we would see a dry season there. So what I have here, the next couple of slides are going to show the impacts of various regions. So I've made a graph here for temperature and rainfall for Mumbai, India. And Mumbai is located right along the coast. It's one of the larger cities in India, I believe. So the blue line here is temperature, or the blue bars are temperature, and the red bars are rain in inches. And what I really want to point out here is it's very clear that the temperature does not range. There's not a huge range in temperature, right? Doesn't have like a generally cold period or a really hot period. But the rainfall, we can definitely see a huge uptick in moisture and in rainfall. And check this out. So here's our axis for telling us rainfall totals in inches. Over 30 inches of rain on average for the month of July from Mumbai. That is wild. For context, San Francisco Airport on average sees about 15 to 20 inches of rain a year. A year! And they get over that in a month. I just think that is so freaking wild. And the reason that this is important is because in these areas, the infrastructure generally is not that great. And flooding is the number one meteorological killer. Water does not care. Water is way, way, way more powerful than any human. And so it can sweep you away. I mean, even just 6 inches of rain can knock an average adult off their feet. So it's very common for flooding instances to happen like this. And we're even experiencing it this year, right, with the amount of rain that we've gotten. And so our soils are saturated, meaning that they can't hold any more moisture. And that can oftentimes happen in places like this as well. So I just wanted to show some pictures of what some of the flooding damages can look like and what exactly that looks like. And it is also expected that with climate change, the monsoons in South Asia are expected to worsen. Not necessarily that the frequency is expected to increase, but the intensity is expected to increase, which is kind of scary, especially for those regions. Next, I want to look at the Sahel and the Sahara Desert. So we have our tropical rainforests in, the Congo, which is we have the Sahel here, and then the largest desert on Earth of the Sahara Desert. So when the ITCZ shifts northward in July, this allows for some greening of the Sahara Desert, which I find to be really, really fascinating. And if these rains don't come, then that can have some seriously negative implications on the wildlife that relies, or wildlife and humans actually, that rely on the water that comes from these monsoon events. So if you ever watched like any of the Planet Earths, like there's the desert episode, and these huge African elephants are trekking along for days and days and days and days, and like these old trails that they remember. And but then if they get to a spot and the water's not there, then they can die. Like it's really sad. But just wanted to show a similar graph that I had for Mumbai, but this is for Niamey, Niger. So I chose some place that's kind of right on the edge of the Sahel and this Sahara Desert, just to kind of show that even if they are kind of far away from the ocean, from the Gulf of Guinea in this case, we still see a pretty stark increase in rainfall for the summertime. But one thing I want to point out here is that the rainfall total in inches is much less than in India. Only just short of 8 inches as opposed to over 30 inches, which is really wild, I think. Last little bit that I want to touch on in terms of monsoons is that we have one here in North America as well. So we have a wind shift that occurs in the southwest U.S., impacting regions like Arizona, New Mexico, and Southern California. And because of this wind shift, we get really intense rain showers in the area, and super dangerous flooding, flash flooding can occur in these canyon regions. So again, same graph or similar graph for Tucson. If you don't know where Tucson is, it's right there. But once again, we can definitely see a dominating wet season versus kind of a dry-ish season. And once again, just pointing out that the average rainfall is way less than even Africa, but especially Mumbai. So the last little thing I want to touch on in terms of wind variation is looking at the topographic effects of winds, meaning the mountains and the mountains and valleys and that kind of circulation. So air is forced to rise over a mountain and sinks on the other side. Excuse me. And then as it rises, it can start to condense and make a cloud. And if those clouds get too full, if they're too saturated, then they'll precipitate, which then effectively removes moisture from the air. And as it goes down on the other side, it warms and sinks and compresses. So without any moisture, the subsidence then creates a drier region. And what better example than the Pacific Northwest? This is Washington and Oregon, and we can see here that on the left side or on the west side, it's way more green, right, than in the center, which is way more brown, indicating that the mountains are very greedy and they take all the moisture and leave eastern Washington and eastern Oregon basically into a desert, which is really quite fascinating. So if you've ever wondered kind of why Nevada and Utah and eastern Washington and Oregon are deserty, it's because when we have air being forced over the Cascades and over the Olympic Mountains and even the Sierras and coastal mountains here in California, then we take it all, which is great for us, maybe not so great for these high desert regions. So the next video will include tropical cyclone information. So I'm super hyped for that stuff. And thanks for watching.